Hi everyone, welcome to the 9th lesson of the CrowPanel Pico HMI Display Series tutorials. In this lesson, I'll show you how to create an interface to control a servo motor using the slider widget in SquareLine Studio. The lesson will be divided into 3 parts. First, designing the UI. Second, modifying the example code. Third, editing the UI code. Moving forward, let's demonstrate the first step. First, open SquareLine Studio and design a UI interface to control the servo motor's rotation. To create a UI project, I won't go through the entire process in detail. However, if you're unclear about why you're creating it this way, please review the content in Lesson 6 first. Once created, we need to find the slider widget, add it to the interface, and adjust its size accordingly. Of course, apart from the slider, another commonly used widget for controlling the servo motor is the arc widget, which should also be added to the interface. Since there are only 2 widgets, I've made them as large as possible. Additionally, I need 2 labels to display the current values of the widgets. One goes in the middle of the arc widget, with its content modified, and the other goes below the slider. Once the interface design is finalized and all the widgets are in place, if you wish to achieve the rotation of the servo motor in accordance with the changes in the widget values, you'll need to add events for these 2 primary widgets. First, select the slider widget and add an event in the inspector panel. Set the trigger to occur when the variable changes, then select the action to be triggered, which is call function. You can customize the function name, and we will add the function content later when modifying the UI file. Similarly, add the same event to the circular arc component with the same trigger and action. After the settings are complete, you can simulate the effect. Note that the radius of the circular arc component is too large since I'm using an SG90 servo motor, which only rotates 180. I've modified the value of this circular arc component and the background arc in the inspector panel on the right to range from 0 to 180. At this point, you may find the circular widget's usage feels a bit unnatural. Don't worry, just find the rotation section where you can adjust the direction of the circular widget. Rotate it 180, and that's it. Then you can adjust its size accordingly. Next, let's set a range for the value of the slider widget to match the rotation angle of the servo. Finally, conduct another simulation, and if there are no issues, you can export the UI file. Click on File and open Project Settings to set the save path for your project, the export path for UI files, and the export rules for UI files. These steps were covered in Lesson 6, so I won't explain the reasons behind each action here. After you've made your settings, click Apply Changes, then click Export and select Export UI File. After exporting the UI, first locate the example code for this lesson from the course files. If you're unsure where to download the course files, you can find the download link in the video's description. Once you've found the appropriate example code based on your board's dimensions, copy the recently exported UI file into the same folder as the example code. This way, when you open the example code, the UI file will also be opened simultaneously. Now moving on to the second step, modifying the example code. This step is quite simple, as the example code has been used numerous times. Therefore, you just need to confirm if the necessary changes have been made in the specific places. First, check if the header file UE is included, and if the 2 headers related to demos are commented out. As they have already been modified, there are no issues there. Finally, make sure that the UI interface loading function has been added to the setup function. Alright, modifying the example code is complete for this step. Next, for the final step, we'll modify the UI file and switch to the UI event. C file. This is where the functions I created in SquareLine Studio reside. You can find the trigger conditions for these two functions in the UI.C file. In the slider event, you'll notice that the slider changed function is triggered when the slider's value is changed. This aligns with the settings I just configured in SquareLine Studio. Similarly, the Arc widget's events follow the same principle, with only a difference in the function being called. Alright, let's take a look at what these two functions are supposed to do after sliding these two widgets. My idea is that when the slider is moved, we first need to read the current value of the slider. And then the servo motor rotates to a specific angle based on that value. So, I'll need to declare a variable to store the current value of the slider. But which function should I use to get the current value of the slider? You can search for LVGL doc, open the official LVGL documentation, find the slider widget in the widget section, click on the API, then click on the LV slider page, and you'll see all the functions related to the slider. The one I'll be using is getValue. I'll copy that into the slider changed function. The first parameter is the object being operated on. You can refer to the function that determines the event trigger condition, and use that function to retrieve the slider object based on the passed-in parameters. Alternatively, you can directly find the pointer to the slider in the UI.C file and use that pointer to specify the slider. Clearly, using the pointer approach is more convenient, so I've chosen to use the pointer as the first parameter. However, when I slide the slider, the Arc widget should also change, and both widgets should be synchronized to make it logical. Therefore, I also need to add the operation to set the Arc widget's value within this function. Open the LVGL documentation, navigate to the Arc's API page, find the setValue function, copy it into the slider change function, and fill in the required parameters, the value to set and the target object. Similarly, following this logic, I would add a similar function in the Arc changed event handler to synchronize the value of the slider widget when the Arc widget's value changes. It's worth noting that when setting the value of the slider widget, we also need to determine the third parameter. To improve efficiency, I will choose to disable the animation. In order to let the function controlling the servo know when it needs to rotate, I added a variable to both functions as an indicator of whether the servo requires rotation. Since it needs to be called from other files, it must be a global variable. Therefore, it also needs to be declared as an external variable in the UI file. Next, switching to the demo file, I plan to add code to the loop function to control the motion of the servo. First, I will use a flag variable to determine if the servo needs to rotate, and then add code to control the servo's motion as needed. To control the servo, I will use the RP2040 ISR servo library. Click on Sketch, find Include Libraries, and open the Library Manager. Search for RP2040 ISR servo, select the latest version, and install it. Add the library header file to the sample code. Next, create a servo object. Name it MyServo, and use the setup servo function in the setup function to attach it to pin 28. This pin 28 corresponds to the GPIO port on the development board. Lastly, I just need to finalize the code for servo rotation using the function. I'll specify the rotation angle as a parameter. This angle can be obtained from the value of the slider widget using the getValue function. Once the rotation is complete, remember to reset the flag. That's it. Furthermore, I remembered that I had added 2 labels in SquareLine Studio, but haven't utilized them yet. As I open the LVGL documentation, I found an interesting function in the demo code for the slider page called LV which is similar to the sprintfi used in the previous lesson. I copied it into the loop function, declared the necessary parameters, modified the content displayed by the labels, and specified the objects for manipulation. After concatenating the text, I used the setText function to update the content of the labels. Since I needed to use 2 labels, I copied and pasted the code segment below, made the same modifications and double-check the labels corresponding to these two widgets. The ARC widget should be using label 1. Alright, all the modifications to the UI files have been completed. Next, use a USB-C cable to connect the board to your computer and configure the compilation settings. Once done, you can upload the code. I won't go through the process of configuring the compilation settings in detail. If you're still unclear about how to do it, please refer to the content of the first lesson. After configuration, click Upload to upload the code. The upload process can be quite slow, so I'll speed up this part of the video. Once the code is uploaded, you'll see the screen displaying the UI design you just created, and you can control the servo motor's movement using the slider widget and arc widget on the UI. That's all for this lesson. If you find my course helpful, please don't forget to like and subscribe to my channel. See you next time.